All right, so we're beginning Unit 3. Unit 3 is all about polynomials, and today we're specifically going to look at power functions. Okay, so we define a power function as f of x equals x to some power n here, and n is called the degree of the function, and it's an integer, always going to be an integer, no fractions in our exponents here. It's an integer greater than or equal to 0. Okay, so it could be 0, it could be 1, 2, etc. on to infinity. If n is equal to 1, then what we get is f of x equals x to the first power, and so that's going to be just linear. If n equals 2, we get f of x equals x squared, and remember that we call that quadratic. Okay? So number 1 here says graph the following power functions on the windows from -5 to 5 for x, -5 to 30 for y. You can use, if you have your graphing calculator, you can do it on the graphing calculator. There's a window button up toward the top. I think it's a little bit easier to see on Desmos on your computer. So that's the way I'm going to be doing this. I'm going to be graphing this on Desmos. We're doing x squared, x to the 4th, x to the 6th, and x to the 12th. So I'm going to turn on my little thing here. Alright, so here we go. I think you can see that okay. Alright, so you can see I have graphed x squared, x to the 4th, x to the 6th, and x to the 12th. The one on the outside here is x squared, and the next one is x to the 4th, and then x to the 6th, and then x to the 12th is the one on the inside. Alright, and you can see as the numbers go up, alright, they get thinner, and down at the bottom it gets a little bit squarer looking, so that like this blue one, which is x to the 12th, comes down and it's on the outside. When you get down in here, it is on the outside, whereas this green one, which is x squared, is the innermost. It's the innermost line going through between -1 and +1. You can see I set the window here from -5 to 5 and from -5 to 30 like it said. And the way you set your window on Desmos, just in case you didn't know this, is there's a little wrench up here in the right hand corner. If you click on that, you can, if I just touch that right there, now you can set your x-axis and your y-axis, your scales and stuff right there. Alright? Okay. So now that we see this, let's answer the questions. It says compare the graphs. They have the points blank in common. Well, they're all going to go through 0, 0. And you can see they're all crossing right here at 1, 1. And they're all crossing right here at -1, 1. So they have 3 points in common here. 3 points in common. -1, 1, 0, 0, and 1, 1. Okay, so let's set that aside for just a sec. For f of x equals x to the n, where n is an even positive integer, first of all, it has y-axis symmetry, so this is an even function. Function is even. And when we're to the left of -1 or to the right of +1, the graph gets steeper as x increases. As we use larger values of x, then this becomes a skinnier graph because it's steeper outside of 1. Between -1 and 1, however, the graph gets flatter. So the higher the number, like x to the 12th, it's steep, but then when it gets to 1, it gets a lot flatter through here. Okay? Alright, we haven't really talked about end behavior yet, but in behavior, we describe in behavior as what's happening to the graph as we go to positive infinity or negative infinity. In other words, as we go to the ends of the graph, the right end or the left end, what is happening on the graph. With polynomials, they will always go either to positive infinity or they'll go down to negative infinity. Okay? With other graphs like rationals, we often have asymptotes where you get closer and closer to an asymptote, but on these they'll always go either to positive or negative infinity. So on this particular one, this is saying as x approaches negative infinity, in other words, as we go far to the left, or as x approaches positive infinity, we go far to the right, always f of x is going to go up. It's going to positive infinity. Okay? Whether we're going far to the left, far to the right, f of x is always going to go to positive infinity. It's going up if we have an even number as the exponent. All right? Okay. So you can see here now we are looking at x to the third, x to the fifth, x to the seventh, and x to the 11th. And once again, x to the third is the widest one, come out on here on the edge, the green one. And next is going to be x to the fifth, and then x to the seventh is the red, and then the innermost here, the blue, is x to the 11th. Okay? They have the points blank in common. Kind of hard to see here. Okay, so I've zoomed in. Instead of being negative 30 to positive 30, I'm looking at negative 10 to positive 10 now. And we can see we know that they're all going to cross at 0, 0. That's pretty clear. We can also see they all cross right here at negative 1, and they're all crossing right here at positive 1, positive 1. Okay, so once again we have 3 points in common. We have negative 1, 0, 0, positive 1, positive 1. Okay, so once again you can also see that as I get a higher power, then it gets steeper through here, and then it's also a higher power makes it flatter as it passes between negative 1 and positive 1. So we're going to fill that in here. Alright, first of all, odd positive integer for x to the nth power, where n is an odd positive integer. The function is an odd function now. To the left of negative 1, to the right of positive 1, the graph gets steeper still, just like on the others, as n increases. And between negative 1 and positive 1, the graph gets flatter as n increases. So the end behavior is I go to the left as x approaches negative infinity, then f of x, the y value, is going down. It's going to negative infinity as well. As x goes to positive infinity, as I go to the right, f of x, the y value, goes to positive infinity. Okay? Alright. So I kind of skipped ahead here, did a little pre-work. So f of x equals x cubed. I just put in the values negative 2 to positive 2 here. So negative 2 cubed is negative 8. Negative 1 becomes negative 1, 0, 0, 1, 1, and 2, 8. Graph those. Here's my cubic function. Domains are real numbers. Ranges are real numbers. Goes down forever, not forever. Characteristics. It is an odd function, meaning it has origin symmetry. It is 1 to 1. And it increases on its entire length, right? From negative infinity to positive infinity, it's always increasing, and it has an x and y intercept at 0, 0. Okay? X to the fourth. The reason we're looking at cubic and quartics here is that we're going to be using these for transformations on the homework and on the back side of this last page as well. We're going to have some examples of cubic and quartics and transformations. Alright, so x to the fourth power. If I put in negative 2 to the fourth power is 16. Negative 1 to the fourth power is a positive 1. 0 is still 0, 1 is 1, 2 is 16. So graphing this, you can see it's a little bit flatter than a normal parabola. It's going through 1, 1, but then 2 16's off my graph. So it doesn't even, I just pointed up there. Doesn't even get to 2 before it goes off. Domains are real numbers, negative infinity to positive infinity. The range now is only from 0 to infinity inclusive, and it is including the 0. This is an even function. Even function, it has y-axis symmetry. It is not 1 to 1. So it is decreasing from negative infinity to 0. It's going down from left to right, and then it's going up from left to right from 0 to infinity. All right? And once again, it has intercept. The only intercept is at 0, 0. Okay. So disregard this right here for just a minute. I'm going to graph the following transformations of f of x equals x cubed. Oops. There we go. F of x equals x cubed and f of x equals x to the fourth power. So I've got f of x equals x minus 3 cubed minus 2. So I've got this minus 3 and a minus 2. The minus 3 in the parentheses, remember in the parentheses is going to shift left and right. So minus 3 is going to do the opposite of what I expect. I would think minus 3 would be 3 to the left, but no, it's going to be 3 to the right. This minus 2 outside, any kind of minus or plus outside, it's going to shift up and down. It does exactly what you think. If you have a minus 2, it's 2 down. If you have a plus something, it's going to be up that much. So I'm going to shift right 3 spots and 2 down. So let's start with our 0, 0, because the graph we know of, this is the basic function here, is f of x equals x cubed. So we're going to start with 0, 0, and we're going to move it 3 to the right and 2 down. So if I started at 0, 0 here, went 1, 2, 3 to the right and 2 down, that's now like my new 0, 0. And from there, I'm going to go to 1, 1, so 1 to the right and 1 up. I'm going to go to negative 1, 1 to the left and 1 down. I can go 2 to the right and 8 up, 1, 2, 3, 4, 5, 6, 7, 8. And I can go 2 to the left and 8 down. And I can just check those points if I want with the equation. I can put in, for example, at 4, actually at 5. If I put in 5 for x, 5 minus 3 would be 2. 2 cubed is 8. 8 minus 2 would be 6. So at 5 I should be at 6, and sure enough I am. If I put in 1, 1 minus 3 is negative 2. Negative 2 cubed is negative 8. Negative 8 minus 2 is negative 10. And at 1 I'm at negative 10, so that works as well. The domain is all real numbers, negative infinity to positive infinity. The range is all real numbers as well. Okay? All right, let's look at number 4. We've got negative 1/2 x to the 4th plus 4. So I've got a negative sign does an x-axis reflection. The 1/2 makes a vertical shrink times 1/2. And then up 4 from the plus 4 here. Notice it's not in parentheses, so it's going to be up and down. All right, so with x to the 4th, remember it's that flat quartic. So first thing I'm going to start is at 0, 0. I'm going to go 4 up. The x-axis reflection, the vertical shrink won't affect that first point. But I'm going to go 4 up from 0, 0. So 1, 2, 3, 4. So 0, 4 is on it. Now, if I go 1 to the right, I'm only going to go a half space down. Normally I'd go 1 to the right and 1 up. But since it's an x-axis reflection, I'm going to go 1 down. But then I have a vertical shrink of a half. So it's only going a half space down. Same thing, 1 to the left and a half space down. If I go 2 to the left, 2 to the right, normally I would go 16 up, but in this case I do half as much and I'm going down. So I'm only going to go 8 down. 1, 2, 3, 4, 5, 6, 7, 8 right here. And same thing, negative 2, 2 to the left and 8 down, puts me right there. And then I can just draw my graph, and it gives me a pretty good little example of that negative 1/2 x to the 4th plus 4. Okay? All real numbers is my domain. And this time it's negative infinity to 4 inclusive for my range, from 4 down. All right. So write the function for the following graphs. So let's talk about first what transformations are going on here. Normally this is a cubic. This is pretty clearly a cubic. But normally a cubic will do like this and be down on the left and up on the right. This one's up on the left and down on the right. So I've got an x-axis reflection. That's one thing that's going on. The other thing that's going on is it's been shifted 3 to the left. This is my center point. Instead of it being at 0, 0, I'm 1, 2, 3 to the left. So I have x-axis reflection and left 3 here. Okay? So my equation, the x-axis reflection will be negative 3 to the left. Normally I would think it'd be a minus 3, but remember inside it's going to be the opposite, so plus 3, and then I want to put that cube there to make sure it's a cubic. And that's it. Negative of x plus 3 cubed. All right, let's look at this one. This one's a quartic. Okay. Right off the bat, I can see instead of being centered at 0, 0, I'm 1, 2, 3, 4, 5 down. So it's been shifted down 5. And notice they put this dot on here to point out, it's not, I'm not going over 1 and up 1, I'm going over 1 and up 2. So that's a vertical stretch. A vertical stretch times 2. And I think that's pretty much all that's going on. It's going down 5, vertical stretch times 2. So I'm going to say 2x to the 4th, and then down 5 would be a minus 5 here. 2x to the 4th minus 5 should be the equation for that. And you can check these on Desmos if you want. You can put these equations in Desmos and see if it gives you the right picture. All right, that's it. If you have any questions, shoot me an email. I hope you're all doing well. We're starting off a new 9 weeks, so let's start it off on the right foot here, okay? Talk to you later. Bye-bye.